This is PreCalculus 12, Chapter 2.3. We're going to be analyzing rational functions algebraically. So rational functions, again, are P over Q, or numerator over denominator. And the domain is all reals except for where there are NPVs. And let's look at the properties that we've discovered. Where are the vertical asymptotes or holes? They're at the zeros of Q of x, which is the denominator. When do we have holes versus when do we have vertical asymptotes? We get holes when we can cancel out a factor from the denominator with P of x, or the numerator. Otherwise, it's a vertical asymptote. So we get holes when we can cancel out common factors. Otherwise, it's a vertical asymptote. Where do we get horizontal asymptotes? When the degree of Q of x is greater than or equal to P of x. So if the degrees of the numerator and denominator are equal, then we have a horizontal asymptote of y equals a over b, where a is the leading coefficient of the numerator and b is the leading coefficient of the denominator. Otherwise, if the degree of the denominator is greater than the degree of the numerator, the horizontal asymptote is y equals 0. And the reason for that is if the denominator has a bigger degree than the numerator, the denominator is going to grow faster, which means we'll go towards 0. When do we get a slant asymptote? When the degree of the numerator is 1 bigger than the degree of the denominator. And there also has to be a vertical asymptote, which means that there's a remainder. We have to calculate the slant asymptote with a polynomial division. So we take the coefficients, 2, multiply, -6, add, -3, multiply, add. Okay, so there's a remainder here. So there is a slant asymptote, and the slant asymptote is the quotient. So we have 2x minus 3 is the slant asymptote. Technically, we would write out plus 14 over x plus 3, but the slant asymptote is this. This will go to 0 when it's going to infinity. So if we have an expression like this, we can cancel this out. So this is x plus 1. Because we've canceled everything out, there's no remainder. So this is just a line with a hole. Because the other way to look at it is there is no vertical asymptote. Okay, so there's no vertical asymptote, there's no remainder. And if we look at one more example, we look at this expression, we can cancel this out, but we have a vertical asymptote here. So that means we do have a slant asymptote. The degree of the numerator is 1 bigger than the degree of the denominator. And we can also test this out by doing the division. Let's multiply this out. This is x squared minus x minus 20 over x minus 4. So if we do a division, we have 1, negative 20, and we're dividing by 4. 1, 4, 3, we're adding, multiply, 12, -8. So there is a remainder. Okay, so our slant asymptote would be y equals x plus 3. Let's look at a few more examples. Fastest way to do this algebraically is to factor. This is already in factored form, so that makes it easy. We can just analyze this. We have a whole, and we have vertical asymptotes. X equals 1, x equals 4. Degree of the numerator is 2, degree of the denominator is 3, so that implies that our horizontal asymptote is y equals 0. So if we look at this, we can see that the curve approaches y equals 0. It would be incorrect to say that this is a horizontal asymptote. That's wrong, because the values don't approach here at infinity. Now if we look here, and draw our vertical asymptotes, x equals 1, x equals 4. It's a little difficult to see that this is the vertical asymptote because this is very far away. So you need to make a larger range. But the larger range makes it a little bit more difficult to see your horizontal asymptote at times. Next one. This one is not factored. So let's take a look at the denominator. There's no zeros. Okay, so no vertical asymptotes. And how do I know this? We check discriminant. B squared minus 4ac. So we have b is 1 squared minus 4 times 2 times 7. We don't need to evaluate this. 1 is a lot smaller than this, so this is going to be very negative. So there's no real roots. One other thing we need to check is horizontal asymptotes. Degree 2 over degree 2. So horizontal asymptote, y equals 4x squared over 2x squared. These cancel out and it's equal to 2. Y equals 2. That's our horizontal asymptote. Let's take a look at the next problem. Okay, we try to factor the numerator, x plus 3, x minus 2, x plus 1. Okay, this is negative, so we have to have a positive and a negative. And because this is a plus, the positive factor needs to be bigger than the negative factor. No common terms. We have a vertical asymptote. X equals negative 1. So again, the range could be a little bit larger. That way you'll see that this approaches the vertical asymptote and this approaches the vertical asymptote. We have degree 2 over degree 1. This means we need to compute the slant asymptote because we do have a remainder. So we take the coefficients. 1, 1, negative 6, and we have negative 1. Remember, we change the sign. because it's x minus a. Bring down the 1, multiply, -1, this is 0, multiply 0, our remainder is -6. But our slant asymptote, y equals x. So we have y equals x, and that's y equals x. And here we have x equals -1. Let's look at the next problem. Okay, again, this is all factored out for us. No common factors. This is vertical asymptote. And we have x equals -1, x equals 4. X equals -1, x equals 4. Degree of the numerator is 4. Degree of the denominator is 2. No horizontal asymptote. Okay, we only have horizontal asymptotes when the degree of the numerator is less than or equal to the degree of the denominator. I've shown you what window we use to graph this. You'll have to learn how to play with the domain and range until you're able to see all the key features of the curves. For now, you'll have to use the graphing calculator. In the next chapter, you'll learn how to graph this by hand. And if you've forgotten how to graph these, please refer back to chapter 2.2. And that completes this lesson.